I'm going to use the northwest corner method to find the initial basic feasible solution of this transportation problem here. We have three sources, F1, F2, and F3, and four destinations, A, B, C, and D. So to find that initial basic feasible solution using the northwest corner method, we start by looking at the northwest corner cell. So when we are looking at the compass there, the northwest corner cell is the top left-hand corner cell. So we look at these unoccupied cells, cells that do not have an allocation, and then go on to look at the top left corner. The top left corner, which we are now calling the northwest corner, is this one here. So to see how much we can allocate, we look at the supply and the demand, which is a 10, and then take the minimum of that supply and the demand that I've highlighted. The minimum of 20 and 10 is a 10, so we allocate 10 units in this cell. But the moment we allocate 10 units in this highlighted cell, we have reached the demand constraint for column A, which is a 10. So I would have to cross out all other cells in this column to indicate I can no longer allocate anymore. So I'll cross out here and cross out here. But when we allocated these 10 units, we were having a supply constraint of 20. So we subtracted the 10 from the 20 and we will remain with 10. So we are now remaining with a supply of 10 for source F1 there. And then we go on to the next step, which is to look at the remaining unoccupied cells. So for the remaining unoccupied cells, we then go on and look at the top left corner cell of the unoccupied cells that are remaining. So that cell is this one here. To see how much we can allocate, we look at the supply. We are having a 10, and the demand, we are having a 15. So to see how much we can allocate in the highlighted cell, we look at the minimum of the 10 and the 15, so we allocate 10 units. But the moment we allocate the 10 units there, that means we have reached the supply constraint for F1, which is a 20. So we can no longer allocate in a row F1 there. So we'd have to cross out to indicate we cannot allocate here, and cross out to indicate we can no longer allocate here, since we have reached the supply constraint. But when we allocate the 10 units here, what we'll be left with here on the 15, it will be 15 minus 10. So we are remaining with 5 there. And then we go on to the next step, which is to look at the northwest corner cell on the remaining unoccupied cells. So that cell is this one here. To see how much you can allocate, we look at the supply, it's a 25. And then the demand, it was a 15, but we are now left with 5. So we allocate the minimum of 5 and 25. So the minimum there is 5. So we allocate 5 units. But the moment we allocate 5 units, we have now reached the demand constraint for column B. So we can no longer allocate anything more in column B. So I would have to cross out here to indicate we can no longer allocate. And then when you allocated this 5, it will remove from the 25 the supply, so we'll be remaining with 20. And then we go on to the next step, look at the northwest corner cell of the remaining unoccupied cells. So that cell there is this one here. To see how much we can allocate, we look at the supply. We were having 25, we are now left with 20. For the demand is a 15. So we take the minimum of the 15 and the 20, and that minimum there is a 15, so we allocate 15 units here. But the moment we allocate the 15 units there, we have now reached the demand constraint for column C. So we can no longer allocate in column C, so I would have to cross out here to indicate we can no longer allocate. And then when we allocated this 15, we will subtract it from this 20 and we will remain with a 5. Then we go on to the next step, look at the top left-hand corner cell on the remaining unoccupied cells. The top left-hand corner cell there is this one here. So to see how much you can allocate, we look at the minimum of the supply, which is a 5, which is left, and the demand, which is a 20. So we take the minimum of the 5 and the 20, that minimum is a 5. So we allocate 5 units here. But when you allocate these 5 units for the demand, we have to adjust it here because it was 20. We have taken 5, so we remain with 15. So I put a 15 there. And then we go on to the next part. We only have one cell which is remaining. So we have to allocate in this cell here. To see how much we can allocate, we look at the supply, which is a 15, and then the demand is a 15 as well, which is left. So we have to allocate 15 units in this cell. Every cell now has an allocation or has been crossed out. So we are done with the allocations. So we can just go on and look at the interpretation of what this is saying. So what we are having there, I will draw a table where we have the destination, the allocation, and the cost. So looking at the table there, where we have this 10, we are saying from F1 to A, we are allocating 10 units. And the unit cost there is a 10. So for the cost of transporting those 10 units, it will be 10 times 10, and it will give us a 100. And then we go on and look at this part here from F1 to B. We are saying we are allocating 10 units. So I will write my allocation 10 units, and the unit cost there is a 0. So the total cost will be 10 times 0, which will give us a 0. Then we go on to the next part where we have an allocation, this one here, from F2 to B. We are saying we are allocating 5 units. 5 units at a unit cost of 7. So the total cost there will be 5 times 7, which gives us a 35. Then we go on to the next part. This one here, we are looking at F2 to C. We are saying we are allocating 15 units. So the cost there will be 15 times 9, which will give us a 135. And then we go on to the next part. This one here, we are now looking at F2 to D. So for F2 to D, we are allocating 5 units. 5 units at a unit cost of 20. So the cost will be 5 times 20, which gives us a 100. Then lastly, we look at this one here. We are looking at F3 to D. We are allocating 15 units. 15 units at a unit cost of 18. So the cost there will be 15 times 18, which will give us a 270. Then we go on and add the cost that we've just obtained, and then we get that the total cost there is 640. So the initial basic feasible solution using the northwest corner method is giving a total cost of 640. But one thing to note, if you look at this cell here, we are having a unit cost of 0. A unit cost of 0 means that no transportation costs have been incurred. And this arises, for example, if a factory has a shop at the same premises where they are manufacturing the goods. So in this case, the goods are manufactured and there is no transportation cost to where they are now sold. So the transportation cost there will be a 0. I'm going to use the northwest corner method to find the initial basic feasible solution of this given transportation problem. S1, S2, and S3 are the sources, D1, D2, D3, and D4 are the destinations. So to use the northwest corner method, we start at the top left corner, and that is the northwest corner. So if you are looking at our compass here, the northwest corner is the top left-hand corner. So we look at these cells that don't have an allocation, they are unoccupied cells. And these values here in these small squares are indicating the unit costs. So for this case, the northwest corner cell is this one here. To see how much we can allocate, we compare the supply, the 30, and the demand, which is 35. We take the minimum of the 30 and the 35, and that's a 30, so we allocate 30 units. But when you allocate 30 units, we have reached this supply constraint. So that means we can no longer allocate in row S1. So we'd have to cross out all other cells in the row S1 to indicate we can no longer allocate. So I'll cross out here, cross out here, cross out here, indicating we can no longer allocate. But for the demand, we have allocated 30, but we're having 35 here. So we are still left with 35 minus 30, which gives us a 5. Now we go on and look at the unoccupied cells that have not been crossed out. So we are looking at these cells here. Look at the northwest corner cell. The top left-hand corner cell is this one here. To see how much we can allocate, we look at the supply, it's a 40. And the demand, we had a 35, we are now left with 5. So we take the minimum of 40 and 5, that minimum is a 5. So we allocate 5 units. But when you allocate 5 units there, the total for column D1 is now adding to 35, which is the demand there. So we have reached the demand constraint, so we can no longer allocate anymore in column D1. So we go on and cross out this one to indicate we can no longer allocate. But for the supply here, we had 40. We have just subtracted this 5, so we are left with 35. Then go on and look at the remaining unoccupied cells. We are looking at these cells here. So we take the northwest corner cell, which is this one here. To see how much you can allocate, we look at the supply. We are left with 35, and the demand, we are left with 28. So to see how much we can allocate, we take the minimum of the 35 and the 28, and the value that we get there is a 28. So when you allocate 28 units, we see that we have reached the demand constraints for destination 2 there. So we can no longer allocate anymore, so cross out this cell. And for our supply, we were having 35, but we are now subtracting on this 28, so we will remain with 7. And then go on and look at the remaining unoccupied cells. We are now looking at these cells here. Choose the northwest corner cell. The northwest corner cell is this one here. To see how much we can allocate, we look at the supply. We are left with 7. The demand, we are left with 32 there. And we take the minimum of the 7 and the 32. That minimum is a 7. So we allocate 7 units here. But when we allocate the 7 units, we have now reached the total there of 40 for row S2 there. So we can no longer allocate in row S2. So I'll cross out here to indicate we can no longer allocate. And here we just allocated 7 units, but our demand is 32. So we are remaining with 32 minus 7, which gives us a 25. And then we go on to look at the remaining unoccupied cells of these ones here. We take the northwest corner. The northwest corner, we are saying the top left-hand corner. So the left-hand corner cell, in this case, is this one here. To see how much you can allocate, we look at the supply. It's a 50. For the demand, we are left with 25. So we take the minimum of the 50 and 25. That minimum is a 25. But the moment we allocate 25, we were having a supply of 50 here. So we subtract the 25 and we remain with 25. And then we go on to the next step, this cell. That's the only cell that is remaining. So we have to look at how much we can allocate. We look at its supply, it's a 25. Its demand is a 25 as well. So we allocate 25 units in this cell. At this stage now, every cell now has an allocation or has been crossed out. So we are done with the allocations there. We then go on and interpret what this table is saying. So I will draw a table where we have a destination, allocation, and cost. So looking at this one here, we are saying from S1 to D1, we are allocating 30 units. 30 units at a unit cost of 6. So the total cost there will be 30 times 6, which will give us 180. Then on this part here, we are saying that we are looking at S2 to D1. We are allocating 5 units. 5 units at a unit cost of 5. So the cost will be 5 times 5, which will give us a 25. On this part here, we are saying that we are looking at S2 to destination 2, and we are allocating 28 units. 28 units at a unit cost of 11, so the cost will be 28 times 11, which gives us 308. Then on this part here, we are looking at S2 to destination 3. We are allocating 7 units. 7 units at a unit cost of 9, so the cost will be 7 times 9, which gives us a 63. Then go on and look at this part here. We are looking at S3 to D3. We are allocating 25 units. 25 units at a unit cost of 7. So the cost there will be 25 times 7, which gives us 175. And then lastly, we look at this one here. We are looking at S3 to destination 4. We are allocating 25 units. 25 units at a unit cost of 13. So the cost will be 25 times 13, which gives us a 325. Then we go on and add the costs which you have just obtained, and the total that would have there is 1008. 76. So we are saying the initial basic feasible solution using the northwest corner method is giving us a cost of 1076. Thank you.